Hello, in this video we're going to introduce the topics related to Lab 2, which are the user-defined functions and control structures in MATLAB. Here is an overview of what we're going to discuss in details. First, we're going to introduce relational and logical operators, then conditional statements, loops, and how to create a function in MATLAB. Finally, we're going to introduce some useful display commands, and I'll list further examples for practice purposes. Relational or comparison operators in MATLAB include the equal, or simply the equal operator, and it's denoted by the double equal sign. If you want to check whether two variables are not equal to each other or not, you need to use the not equal operator, which is the tilde followed by the equal sign, or the less than operator, the greater than operator, less than or equal to, and finally the greater than or equal. These operators output either a logical 1 or logical 0 if the two operands are scalars. For example, we're checking here as an example whether the degree to rad function, if we call it with 180 degrees, the output of it, whether it is equal to pi or not, and it is true that 180 degrees converted to radians is equal to pi, so this will output a logical 1. Next, we're checking if 5 is not equal to 2, and of course the answer is true, so MATLAB will output a logical 1. Next, we're checking whether 3 by 3 or 3 times 3 is less than or equal to 9. It is equal to 9, so MATLAB will output a logical 1. And finally, we're checking whether 1 over square root of 2 is greater than 1. The answer is false, so MATLAB will output a logical 0. Next, we have the logical operators. So logical operators is like evaluate the Boolean expression that is given. So for example, the logical AND, which is denoted by two signs of the ampersand, so and, will check whether the two operands are both true. If that's the case, it will output a true or logical 1 in MATLAB. As an example, here we have 1 and 1. So true and true is true, so MATLAB outputs logical 1. Next, the next operator is the logical OR, denoted by two OR signs. So as an example, we're checking whether false or false is correct or not. So MATLAB will output logical 0, because according to Boolean algebra, you need one of the statements to be true in an OR statement for the output to be true as well. In the next example, we have a combination of combination of comparison or relational operators along with logical operators. So we're checking whether 2 raised to the power 2 is equal to 4 first, and then if that's true and the other statement, which is the square root of 9, is equal to 3, if both statements are correct, MATLAB will output a logical 1. So this is beneficial when you're checking for conditional statements. So if you need something to happen if something is true, so you'll need to use sometimes a combination of both logical operators and relational operators, just like what we have in this example here. Finally, we have the element-wise logical operators, the element-wise and the element-wise OR. Use these operators on arrays. So for example, here we have two arrays of 3 elements. The first array is 1, 0, 1. The second array is 1, 1, 1. If we put the element-wise AND in between, it means we want to perform this ANDing between each element in the two arrays. So we're going to do 1 and 1, and the output is 1, or logical 1. Next, we're comparing the mid elements in the two arrays. So 0 and 1 is actually 0, so MATLAB will output a 0 in the middle. Finally, we have 1 and 1 is true, so the last element in the output is also logical 1. Moving on to the first control structure that we're going to cover, which is the conditional statement, the if statement. To learn more about the if statement, you can simply type help if in MATLAB. But simply put, the MATLAB syntax for an if statement is as follows. First, you need the keyword if, and then a condition given by the expression, and then the statements that you want to execute if that condition is met. And then in the mid part, you have the else if statement, followed by a condition or a conditional expression. If that condition is met, you want to execute the next set of statements. And finally, you have the else part, which is the default part of the control structure. And finally, the keyword end to indicate that this is where the if statement concludes. Notice that else if is simply just one word without a space in it. And here on the right hand side, we have an example in which we're evaluating two scalars or two variables, x is equal to 2 and then y is equal to 3, and then we're comparing them to each other using an if statement. So we're checking first whether x is equal to y using the equal comparison operator. So if x is equal to y, we want to display in the command window x is equal to y. Else if, or otherwise, we're going to check if x is less than y, and that condition is true, or that expression is true, it's going to output a logical 1. So the condition is met here, x is actually less than y. So in the command window, we're going to see that the statement display x is less than y is going to be displayed in the command window because x is actually less than y. And then MATLAB is going to end the if statement here, even though we have a default case where we're displaying x is greater than y. Another example here, we have two conditions or two expressions that must be true for the first if statement to execute, or to actually execute the statements for that condition. We're checking if x is greater than 0 and y is also greater than 0. Notice that we're using the logical AND, which needs you to use 2 ampersands. So we're checking if x is greater than 0 and y is greater than 0. If that's the case, we're going to create a new variable named f, and then store inside it the result of multiplying x by y. Else, or otherwise, the default statement is this time evaluate f as x divided by y. Now we're going to answer the question, or try to find what the correct value of f is going to be based on the values of x and y that we know, right? It's true that both x and y are greater than 0, so we know for sure that f should be evaluated as x times y, which is 2 times 3, which is 6. So later on in the command window, I typed disp f just for MATLAB to display for me the value of f, which turns out to be 6 as expected. Notice that here the expression and followed by the if or the else if must evaluate to a logical 0 or 1, just like the examples we've done here. And also notice that the else if and the else part of the if statement is optional. The second control structure we're going to cover in MATLAB is loops, starting with the for loop. The for loop has a very straightforward syntax. You first need to use the keyword for and then the keyword end, and in between you're going to put the range for the iterator. So start with the iterator variable, I for example, and then its range. For example, you can say I starts at 1, increments by the default value 1 until it reaches uppercase N. And then in between you're going to put the statements that you're interested in repeating. As an example here we have two nested for loops. The first for loop has an iterator named R that starts at 1, increments by the default 1 until it reaches 4. The second for loop has an iterator named C to indicate the number of columns, and it starts at 1, increments by 1 until it reaches 2. And then inside the most inner for loop, we're creating a matrix named A, and then we're evaluating each element in that matrix each time we enter the inner loop. So in the first iteration, we're evaluating A1, 1 to be equal to 1 by 1, and so on. And then by the end of exiting, after exiting the for loops, I'm typing here A just to output the matrix A to see what it looks like. Next, I have another example in which I have two arrays, X and Y. X is equal to 2, increment by 1 until it reaches 6. So X is equal to 2, 3, 4, 5, 6. And then Y of X is simply Y is equal to X dot power 2, meaning I'm squaring each element in X. So far this is nothing new. And then I'm using a for loop to create an array named F, in which each time I'm entering the loop, I'm evaluating one element in F, starting by F1 and then F2 and so on, such that Fi is equal to Xi squared, meaning F1 is equal to X1 squared, F2 is equal to X2 squared, and so on. So here I'm explaining that this for loop, by the end of it, we're simply finding X squared, the function X squared. So if you use what we've learned earlier, which is the comparison operator equal, and evaluate whether F is equal to Y, we're gonna find out that the answer is actually an array of logical ones, because each element in F is equivalent to each element in Y. Here I'm explaining for loops and how to use the comparison operator for one useful application. And I'm also explaining how MATLAB is easy to use, because instead of using a for loop, which is going to take a lot of processing time, you could simply evaluate the same result using just one simple line of code, which is Y is equal to X dot power 2. Remember that the dot power is the array power, or the array operation, because it's simply squaring each element in X, and the result will be stored in Y. So even though for loops are very useful and they come in handy, in MATLAB there are different ways to do things, and if you can solve the same problem without the use of for loops, it is oftentimes better to solve it without the for loops, just like what we did in this example here. The next type of loops in MATLAB is the while loop. It's also very simple. You need to say while and then an expression. And while that expression is being true, you're going to repeat certain statements. And then you need the keyword end. As an example here, I'm creating a new variable named I, and I evaluated it as 0. So while I is less than or equal to 5 repeats these statements. The statements are display I, and then in text I'm saying squared is equal to, and then I squared. Notice that the plus signs here in the display is simply to concatenate the text that is in between. So display I first, the value of I, and then the text raised to the power 2 is equal to, and then the text or the conversion of I squared into text. And then after displaying the result here, I'm incrementing I by 1. So I'm going to move on to the next I. So first I'm displaying 0 squared, and then 1 squared, 2 squared, and so on, until I is less than or equal to 5. So the last expression that will be displayed is actually 5 squared is equal to 25. So you're going to need an expression that needs to be met. So if that expression or conditional expression is true, we're going to continue repeating the statements and then an end statement. And remember that it is easy to get in the trap of forever loops. So if you encounter a forever loop, or if you fell in the trap of having a forever loop or a loop that loops forever, to stop the command from continuing from the execution, you can simply press Ctrl and C from the keyboard, right? And to avoid forever loops, it's important that at some point in the execution, the expression followed by the while keyword becomes not true anymore. For example, here we're always checking if I is less than or equal to 5, and inside the for loop we're making changes to I, the variable I, so that eventually I will no longer be less than or equal to 5. So the for loop, actually the while loop here, is finite. It will end at some point. Now moving on to the next topic we're covering, which is user-defined functions. It's a very important topic. It's very easy to implement, and you can actually do it from scratch, or you can use the template provided by MATLAB. So to create a function, a user-defined function in MATLAB, you can start from scratch by going to the script file that you're having, and then simply type the function script or the function syntax from scratch if you know it. Otherwise, you can simply go to New and then choose Function. So MATLAB will open a script file, or actually a function file, including the template for a function in MATLAB. The template given has 2 outputs, 2 inputs, and the function name is untitled. Untitled 1, untitled 2, and so on. You can simply modify the template to make it work as your own. So if you no longer need the 2 outputs, you can simply erase one of them and then continue with the template that you are provided. Okay. So if you know how to write the function from scratch, feel free to do that. Otherwise, you can simply click New again, Function. Notice that you could leave the function code in a separate file, but the file name must match the function name, and it has to be located in the same folder you're working with, and that will be considered a global function. But if you want your function to be local to only your script file, or if you want to combine everything in one single file, make sure that you copy the function towards the end of the script file that you want to submit or share or save for later. Here's an example of a script file named practice. I start with the CLC clear all, close all commands, and then adding a comment to explain my code, and here I'm testing my user-defined function. And then the function that I defined myself is located towards the end of the script file. So this is one important notice. So the function name is function name. Again, this is very similar to the template I was provided, except it is kind of simpler or more brief. So if you want something to study from or memorize, I think this one is more concise. So the syntax for a function is simply function, and then you list the outputs. If you have one output, you can simply say y is equal to. Here I have an array of outputs, 2 outputs to be precise, and then equals to the function name, and then brackets, and then between the brackets you're going to list the inputs that you have. And remember that within the function, each of your output must be evaluated or defined, so that by the time you exit the function, all of the outputs will have a value. Here, this is a very simple function in which the output is equal to the input. So output 1 is equal to input 1, output 2 is equal to input 2. And I'm simply testing the function on 2 and 3. So I'm calling the function name 2, 3. So my first input is 2, the second input is 3, and then the outputs are A and B. And then if you click run to run the script file, you will simply see these results. So after clicking run, you're going to see 2 and 3. So A is equal to the first input, which is 2. B is equal to the second input, which is 3. Just a few notes. If you want to submit just one single file, make sure that any user-defined function that you're using is copied and pasted towards the end of the script file, always towards the end of the script file. And if your user-defined function requires only one input, you can modify the template so it will have just one input, and so on. And if your function outputs more than one output, make sure you assigned the output a variable. Just like what I'm doing in this example here, I'm saying the array containing A and B is equal to the function call, right? Another example here, instead of putting the input as scalars or direct values, I'm defining variables. X is equal to 4 and Y is equal to 5, and I'm calling the same function, but this time using variables rather than just direct numbers. So function name X, Y, and I'm storing the outputs in O1 and O2. And since I have a semicolon at the end of the line of code number 5, when I click run to run the script file, you won't see the results of line number 5, but in the workspace you will notice that O1 should have a value equals to X, which is 4, so O1 should be equal to 4, O2 should be equal to 5. As a practice, you can write this code from scratch in MATLAB and modify it. Maybe you can change it so that output 1 will be equal to input 1 times 2, for example, just to play with it to make sure that you understand the concept behind it. Here we have another example in which we're defining a function named tangent that will output the tangent of x, which we know that it's defined as the sine of x divided by the cosine of x. Notice here that in the function definition, I only have one output named y, the function name is tangent, and I have one input named x. And then inside the function, I'm defining each of my output, and I only have one. So y is equal to the sine of x, and then I'm using the array operator because I want my function to work with arrays as well. So without the dot here, my function would sometimes might not work with arrays. So the dot here will ensure that if I have x as an array of more than one element, the function will still work. And then I made sure that the code for the function itself, the user-defined function, is towards the end of the script file. And then I'm testing my function. It is important to always test any user-defined function before you actually put it into use. So this function should output the tangent, which is the sine over the cosine. But there's already a built-in function in MATLAB that does that for me, and the function is tan. So I'm testing my function with that of the built-in function in MATLAB. So y1, the first variable, y1, is equal to the tangent of pi over 2. This is my test, the test of my function. And then I'm testing it using the built-in function pi over 2, the built-in function tan on the same input. So that means if I run the script and both of the functions output the same result, it means my function is correct, at least for this particular test. You can do further testing to ensure that your function is robust enough. Now we're going to move on to some useful display commands, especially now that we're writing our own user-defined functions. The first function is display or disp. We've used this one before. It will simply display as text whatever input you provided. You can say, for example, you can evaluate a variable, x, for example, and then if you want to display in the command window the value is equal to something, you can simply say disp, and then in between quotation mark, the text that you want to display, and then you need a plus sign to concatenate the variable after converting it to text. So this is the way to use this, and you use it to display text and values. And then the other function we want to learn is the error function. You use it if you want to display an error message, usually, or you've seen them, I'm sure. Error messages are displayed in red, and then if your function run into errors, or if your code at some point outputs an error message, it will terminate the execution. So you use the function error as an example, or a useful example, if you designed a function that helps a user divide two numbers, and then if the user inputted the wrong number for the second, or for the denominator, for example, if the denominator evaluates to 0, it means you cannot divide by 0. So a useful application for error, the function error, is if you want to say, hey, you cannot divide by 0. Or if you designed a matrix multiplier, or a function that multiplies matrices, the first thing you need to check is the inner dimension agreement. You can check if the number of columns of the first matrix does not match the number of rows in the second matrix. You're going to output an error message saying inner dimensions must agree, and then the code will terminate. So notice or remember that the function error, not only it will output an error message in red, but it will also terminate the execution. These are further examples. Feel free to practice on them. We'll also try to complete them during the live session, along with some examples from the lab sheets that you're provided. But always remember to follow the steps of problem solving. First, state the problem, describe the input and the output, develop an algorithm, and start proceeding solving the problem. Finally, don't forget to test the solution. Thank you for watching. If you have questions related to the lab topics, please use the discussion forum on Moodle. Otherwise, you can email me at aalatia@auk.edu.kw.